I'd like to share with you all proof of concept work I've been dabbling with over the last few months, and that being looking at some of the tools and features in Surpac Stope Optimizer and applying that in an open pit scenario, particularly around grade boundary analysis. It's very much a proof of concept at this stage, but I do want to share some thinking to date and welcome some feedback or input from you all. Before we get going, let me do a short introduction. As I mentioned earlier, I'm Linda Bateman. I'm a geologist or geology background, principally in the open pit production and resource estimation environment. I've been in Western Australian mining since the early 90s and been a Surpac user since 1999. I joined Dassault Systèmes in May of last year. So a quick overview of what we're going to cover today. For those of you that are principally from an open pit environment, or even if you are underground, just so we're all on the same page, we'll have a run through of what the Stope Optimizer is. We'll then have a look at the second item, the Stope Optimizer in open pits, and how we might use some of the features in the Stope Optimizer in an open pit scenario. The proof of concept discussion and presentation that we'll be having a look at is on dilution analysis on a bench-by-bench basis. We'll pop into Surpac and have a look at that. Finish off with some key points on how you might use the Stope Optimizer in your own particular scenario. Lastly, we'll take questions. We will save questions to the end of the presentation just to optimize the time we have today. Anything I can't get to, or any questions that have or really need a detailed response, I will follow up with you outside of the webinar. I'll start with a high-level view of the Stope Optimizer. So the Stope Optimizer was introduced as a new module in Surpac 219 earlier this year. The Stope Optimizer is used conventionally in an underground mining scenario and is used in the strategic to medium-term planning horizons. The Stope Optimizer allows automated generation of optimum stope shapes, incorporating practical mining constraints and financial models above a cut-off grade or a value. As a bare minimum, this is represented by a cut-off value or grade attribute in a block model. So let's move away from Stope Optimizer's traditional home in the world of underground and understand how it's been applied in an open pit scenario. In order for us to do that, let's understand some workflow fundamentals. I've left the terminology as underground terminology, and we'll break into the open pit slant as we progress. So I've just captured the workflow fundamentals from left to right as you look at them on screen. I've summarized the bare minimum in the black text that's needed to generate some sort of a stope shell output. When I'm talking about a stope shell output, it's really a grade shell output in this open pit scenario. The text that's highlighted in red are additional features that really will allow you to flex and create more realistic mineable shapes when you go to use the tool. Before going into more detail about the open pit scenario, I just wanted to touch on the Stope framework, which is part of the input for the workflow. The schematic I've showing here is showing the typical Stoke framework scenario as applied for an underground ore body. In this particular example, it's a subvertical north-south ore body. The open pit ore body is in fact a similar scenario. In the world of underground, of course, we would be looking at a vertical plane orientation. It's shown here in red, and the squares as defined by section and level spacing is would be the maximum size of the stope panel in this particular case. The blue area is just showing the model space for the stope shape framework. As with any ore body, it'd be great if the ore body behaved itself along strike and down dip and was consistent in dip and strike. So of course the model space, you can break your block model up into domains as the dip and strike changes. Looking at this framework in an open pit scenario, we'd be tipping it on its side. So I've just showed the bench orientation, or that red plane orientation, in blue. So imagine rotating that entire schematic 90 degrees in terms of the stope shape framework. Just stripping all that away, this is just a simplified view of what that framework would look like. I've changed the perspective, so just to put your eye on, this is the y-axis here, the x or cross strike axis. Our ore body lives in here, a north-south ore body, and this is just showing a typical slice for a single bench. In today's example, 10-metre mining benches. Look at the problem statement for the open pit scenario. So often when we're looking at a block model or information that's to hand, it's often a singular view of the ore waste contact. Often it's the optimum view for the mine site. Ore contacts in the scenario, they can be visible or not. And the model that we're dealing with as a geologist is often the in situ model or undiluted model. When we are applying edge dilution, often the edge dilution relies on block maths in the block model to calculate. And this is often just done as a sort of a base factor. Typically a 5% or 10% dilution factor is applied post-mining. It's often very difficult to test dilution sensitivities or scenarios before the bench is mined, or even pre-mining of the in situ block model. You may want to apply different factors, as the ore geometries change of the ore body. If the dip flattens, the strike or plunge changes, how can we control or manage or measure dilution factors easily, or look at scenario evaluation of that. It's also challenging to apply a spatial dilution skin rather than a factor. What if I want to look at a 1 metre dilution or a 2 metre dilution, either pre or post blast? How can I evaluate that, and how can I understand the impact to my tonnes and grade they're going to be pulled from that particular bench? So we're just going to dive out of the presentation for the moment, just pop into Surpac and have a look at the block model that we're evaluating. So I'm just showing here, I'll just turn off that 2D view for a moment. So I've just cookie cut out just because of time limitations. This is 10-metre vertical bench. There's 4 benches altogether. Let's have a look at, just put the 2D back. So these are 100-metre boxes. So we're looking at about 250 metre strike length of this particular kryptonite deposit. If we just have a quick look at a bench, I've just, as in all cooking shows, I'm just going to look at the 410 to 400 bench. And I'll just turn off that 2D plane for a moment just to rotate. And let's just simplify that view for a moment. So I'm just going to just simplify that, and let's just show the ore zone and the contacts of this high grade envelope. You can see that the ore body does vary along strike. It's pretty consistent for the majority of this chunk, but as we head towards the south, the strike does change. So that's an example of where perhaps you'd want to evaluate dilution controls and cut up your block model to look at different dilution scenarios depending on the behaviour of your ore body. I'll just jump back to the presentation briefly. So I'll just present the scenario we're looking at during this webinar. We're looking at a dilution analysis by grade, by bench. I'm just looking at a single bench for today, but of course, as you'll see when I run the optimizer, it's actually running over 4 benches, but I'll just present the results of the uppermost bench, and the trend is the same for the remaining 3, but we'll just focus on a single bench for today. An overview of what the Stope Optimizer is going to run. So for today we are just focusing on the grade sensitivities, and we're looking at lower cut grade sensitivities. Run 4 scenarios to present. I'll just show one just to give an example. So just flexing the lower cut between 55 and 58% to see an impact on bench tonnes and grade for this particular project area. Of course, that could be expanded to multiple elements if you have a polymetallic deposit, or it's certainly possible to set up a product style flag. So if you are blending and meeting a particular product criteria, we could do some more sophisticated block flagging to evaluate dilution or impacts to that particular product. Of course, there's the option to also do dilution skins and do more of a spatial analysis rather than fall back on block maths as been a traditional approach for block model managing block model dilution factors in the past. So certainly that will also allow you to evaluate dilution skins for a single cutoff grade. And you can apply a physical skin, 1, 2, 3 meters, do the 5, 10, 15% dilution as well. That being said, you'll certainly need to ensure that you have a grade model for waste material as well, so you get a meaningful diluted grade when you start applying either lower cutoff grades from your mine cutoff grade, or you are applying dilution skins to your grade envelope. So we'll pop back to Surpac now. Just return to Surpac and we'll run through the setup that I've done. It is a highest level setup today, given the time constraints we have for the webinar. The proof of concept work is an ongoing evaluation. As we develop more depth to this and we expand our thinking on this, we'll share that with updates over the next couple of months with you all. So just to run through the high-level setup for today, I've just set up a project file that's saved. All the settings and setup are saved, so you don't have to reinvent the wheel every time you come back to use the Stope Shape Optimizer. So for today, just doing a base output. So the solid file will have my grade solids, and that'll contain everything that meets my grade cutoff criteria that I'm reporting, and there's a report that summarises that as well. I'm not electing to do any validation files today. They're useful. Certainly if you expect to get grade solids in areas and they don't appear, certainly the validation files will help you piece the story together as to why that may be so. The Stoke framework itself, this is setting up our bench by bench. So effectively, I have got a rotated framework. My ore body strikes towards 330. In the Stope Optimizer, we represent as plus and minus bearing about 0, so minus 34 degrees is the same as 326. And of course, I need to specify my model plane and my intervals, so 10 metre benches, and I'm just going to slice along, imagine walking along a bench from south to north. I'm just looking at that in 20 metre intervals. That'll be predicated by the geometry of your ore body. This is a big, wide, broad ore body, so I'm doing 20 metre slices. I could have done 40 or 50. Again, you can play with those sensitivities when you're doing your evaluation. The slicing interval or slice definition, think of this as a version of discretization to let the Stope Optimizer evaluate grade and cutoff criteria to finer resolution. For the most part, this ore body does strike north-south and dip vertically. To the south, it does swing. So, of course, in the real environment, I would subset my block model and evaluate that separately, but I've just incorporated it for today's presentation. Stope geometry, I've kept nice and broad. I just want to see maximum tonnes and grade that I'm going to get with my grade and cutoff criteria. So I've just specified a minimum mining width, in this case 5 metres. Of course, if it could be 2, 3, whatever that needs to be in your mining environment. The cutoff grade, I'm using a range of cutoffs from 55 through to 58%, and of course we need to, as a bare minimum, specify the density attribute so I can calculate tonnes for each grade shell that's optimised. And I'm just using one of the 3 algorithms that are available to you in the Stope Shape Optimizer. So I'll let that start running now. Even though this is a reasonable data set, it only takes a minute or so to run, so we may as well let it run. So the Stope Optimizer will connect to my block model, and it will start running, and we'll see the process as it works through that. And I'll just drag and drop. Once it's finished, we can have a look at the cells. We may as well let that run today. It's only going to take a minute or so. Okay, and it's done. So the file that's being created is this file. You may remember that from the form. So let's have a look at what that looks like. And I'll just turn on these. So each one of these boxes represents the bench, and you can see there's the 4 benches that have been created. So effectively, imagine I'm at the southern end, walking from south to north, the slice criteria will start walking from west to east. As soon as it meets a cutoff criteria, it'll want to form a grade solid. It'll keep walking across, and when the grade cutoff criteria fails, that will be the edge of my grade my grade envelope. Excuse me. Of course, it doesn't do it as simply as that in the block model. When the Stope Optimizer is creating these solids, it looks at the whole model space. So it's a very powerful engine in terms of looking at the grade and cut-off criteria holistically before it finalises the stope shape itself. Before we leave Surpac, I'll just show, you can see I've got a range of grade solids that I've created using the Stope Optimizer. I've brought them into graphics just to show some of the differences. The suffix just indicates the grade cutoff that I've used for each scenario, and I've just dragged both into graphics, and I've just turned the edges off just to show what this will look like. So you can see, you know, the red is showing, you know, lower grade cutoff. I'm getting additional, well, or let's call it that, due to the lower cutoff constraint. But you can just see the influence of that. You know, today I'm just using the block model. Of course, we could introduce additional constraints to have finer edge resolution. But remember, we're just talking about a proof of concept today, and just playing with grade flexes to see the impact on tonnes and grade on a bench by bench basis. So I've just popped back to the presentation. I've just summarised one of the bench results for this particular project area, just showing the cut-off grade and the resultant tonnes and grade for that cut-off criteria change. And this is just one of a number of scenarios that you could run, keeping it very high level today, but certainly over the coming months we'll look to develop a more sophisticated view of what this could look like. So to finish off, before we take some questions, let's just look at some reasons as to why you could use the Stope Optimizer for a grade boundary analysis. One thing that it is, I think it's good at doing is really looking at that sensitivity testing of ore loss and dilution. You know, quite often if we do a grade control run, or even if you're dealing with an in situ model prior to mining, it lets you run quite a number of scenarios and sensitivity testing to evaluate ore loss and dilution of your ore body. Certainly time-wise, the manual effort to do this, going through creating a manual skin, waste solution skin, introducing maths and complexities into your block model, managing the transparency and the auditability of that is a challenge. And certainly the project files let you evaluate a significant hundreds, if you choose to do so, over a matter of days in terms of time efficiencies. One thing also, I touched on it earlier, certainly for the ore body itself, if your ore body does vary, as they invariably do, in width, dip, orientation, and all the rest, we can certainly set up stope frameworks to better model the dilution scenarios, because they may vary over your pit as your ore geometries change, and you can certainly look at those potential scenarios using the Stope Optimizer. Even bench forecasting, you know, what have we mined, what's next, what have we grade controlled. It certainly lets you look at a range of scenarios for forecasting, you know, identify the best, worst and probable recoverable resources itself. Look, I think that's where we'll leave the presentation today, and we'll be open to your questions now.
I'll just give everyone a minute or so to have a think, just to send through some questions. The questions that you send through to us, I will keep the person or people that ask the question anonymous, just to make that shareable with everybody. As I mentioned earlier, any questions I can't answer today or need to take more time to provide a more detailed technical response, I'll certainly do that. Julia will be taking a note of all the questions that come from you, and I'll get to those over the coming days. I do have a little bit of travel ahead over the next next week, but I'll certainly to give me something to do while I'm travelling to answer to you all. So let me. I've just got one question from one of our attendees, just asking about the ability to show the graphical representation or grade, relative grade of each shape. One thing I didn't make clear, in the stope shapes or grade shapes that are saved, they're saved as Surpac SDM file. So tons and grade information are stored as attributes in that model. There's a few of us, and certainly the person that's asked is logged as a crusader as I am, to have those attributes available to colour and shade, to hide display by that attribute detail. We've got that logged as an enhancement, but at this stage it's not in the release, and I'll have to get back to you in terms of timing as to when that will be so. Thanks for that question. I will save that to share at our meeting next week. You may have noticed also during the presentation, the grade solids themselves, the shapes are very coarse. Certainly for today, I presented very broad parameters in terms of the setup. So using very broad ranges for the edge shapes does result in that those coarse shapes. So that just lets me start from a maximising the grade and tonnage for that. Why use a 20-metre slicing interval? Well, really, just looking at the ore body, that could be one of the parameters you might like to investigate. You know, what's the minimum strike length, for want of a better word, of an ore block? And you can play around with the slice intervals. I use 20. I could equally have used 30, 50. You know, it all depends. Is governed by the ore body that you're evaluating. One thing I should touch on that I didn't touch on earlier, the Stope Optimizer can be recorded in a macro. So all the forms that we walk through, all of those are saved into the macro, and you can certainly set up much more complex parameter settings. I just focused on simple grade cuts today. You could do set up grouped variables to look at grade cutoffs, dilution skins, and so on. Let that run. You know, typically run times for the Stope Optimizer, depending on the size of the block model that they're dealing with, the number of stope frameworks that you're wanting to evaluate over your block model area. You may have more than one stope geometry that you need to use over your block model, and you may need to set up subdomains to do that. You know. Let me have a look. Can the Stope Optimizer be used as whittle? No, it's certainly not recommended. The optimization methodologies are quite different in context of what we're looking at today. It's certainly not being used to optimize a value. It's being used to really test and evaluate dilution scenarios of known grade boundaries or grade contacts. Of course, the Stoke framework that I've set up, I'll just reference a couple of questions that were asked. Perth local time today, earlier this afternoon, my time. We were asked about, why just focus on east-west contacts. Understanding the question that the person was asking. Of course, you're not always dealing with a nice vertical ore body with nice clean ore contacts. If you're dealing with a plunging ore body and you're still dealing with conventional mining benches, it's a great opportunity to set up the Stoke framework to parallel, if you like, that plunge scenario, so you can evaluate dilution factors or impacts of a gently dipping or gently plunging ore body, as the case may be. Look, I don't think we've got any more questions at this stage. Look, if you think of something and you need to ping through an email to us, I didn't show my contact details today, but once we've compiled, we did record the video session both this afternoon and today, local time for today's attendees. We will put contact details there. So if you need to ping a question, look, by all means do so, and I'll certainly make the effort to get back to you. Today is really just a bit of brain food, just to provoke some thinking around, how we might use the optimizing engine that's available to us in the Stope Optimizer in an open pit scenario. I can evaluate hundreds of cut-off grade scenarios, whereas prior to this, it's quite a laborious process and can take quite some time to do. So look, I think we'll leave that there today. And look, thanks again for everyone taking time out of what I know are busy days for everybody. And we look forward to talking with you again at our next webinar. Okay, take care everyone. Bye-bye.